0.5%. Right, but that's huge, 0.5%. And I think, didn't I just, the project you guys just turned in, by the way, how was that? It was good. Basic.
All right. I had to get a little help.
That's cool. Hey, I encourage that. I encourage that anyway. But do you see kind of the value of that math, that project math, interpreting medical test results?
Yeah.
It's absolutely huge because the doctors can't do it.
Well, not to mention the original numbers. I feel like I've heard something totally different. I know the population.
95% sensitivity sounds awesome, right? And then the chance of getting breast cancer is actually 6% if you test positive. It's like, wait a minute.
Yeah.
That's counterintuitive.
Yeah.
Until you break it down using mathematics. I told you the story about my student last term, right?
Yeah.
Her aunt that got breast cancer, false positive. I just, today, coming out of Juniper after swimming, was talking to a guy about it. I don't know how you talking about this. He said, oh, my dad was a statistician. I was like, oh, that's awesome. And he said the book, A Drunkard's Walk. You guys ever read that? It's all about, this guy, the guy who wrote the book, was diagnosed with AIDS because he tested positive for AIDS, was false positive. And he decided, but the doctors apparently completely missed it. Said, oh my God, you've got AIDS. Didn't bother looking at the false positive rates. And as a result of that, wrote a book on Bayesian analysis, which went on to be a New York Times bestseller.
So basically, every time your doctor tells you you have something, go check it.
Good. I want to hear you finish that statement. I wanted to hear, I heard the statement, every time a doctor tells you you have something. I was waiting to see how you finish that. I wanted to see if you were say, don't believe him. Not don't believe him, go check it. Yes. Be skeptical. Don't be pessimistic. Be skeptical. There's nothing wrong with being a good quality skeptical skeptic. Well, and the thing is, you never know if you actually have it. It's all probabilities, right? Eventually you're going to know if you have something. Eventually, obviously, when the symptoms start showing up. But at first, the pre-symptomaticness, pre-symptom, all you've got is probability to work with. If the likelihood says you most likely don't have something, you're most likely not an outlier. Hence by the definition of an outlier, right? If there's a 0.1% chance that you've got the disease if you test positive, and you test positive, you should feel pretty good that you don't have the disease. Because if there's only a 0.1% chance that you do, there's a 99.9% chance that you don't. This is why I wouldn't let my wife get an amnio exam when she was pregnant. They tried to get an amnio. No, she's not at risk. Why? Because if she tests negative, there's a 99.99 chance the baby's fine. If she tests positive, there's a 99.99 chance the baby's fine. So why take the test? If you're not at risk, there's no point of sticking a needle in my wife's belly. Now, back off.
What is it?
It's about.
What were they trying to figure out?
For Downs. For Down syndrome. Because Jen was 32 when we had Max, or when we got pregnant with Max. So, and that's pushing, 35 I think is the cutoff now for at risk, I believe is the age limit. So she's 32, but she's wickedly fit, and I wasn't worried about it. No family history of Downs, no genetic markers. So, but people don't understand Bayesian analysis. You guys do. Hell yeah, you do. And it's so great. Everything from your email accounts blocking spam, to false positive rates, to court, to reliability of court witnesses, all of this stuff falls back on that project you just did. So hell yeah. That's all I gotta say. I'm done. Anyway, well, conspiracy theories generally are based off of unmathematical thought. They have a belief of something, and I'm going to act on it. Usually, honestly, or things that are spoken with great conviction that, as soon as you analyze it, fall apart. So, anyway.
Hey, do you remember that picture you put up, and it was this many people die from guns a year?
Yeah.
That is at the liquor store in Redmond.
Is it?
And I was
I'm
like,
sure
hey, let me tell you why this is bullcrap. And it was so funny. And they're like, we can't go to the liquor store anymore now.
Yeah. There's a picture of me hanging on the wall. Have you seen this man? Tell him to stop educating my children. That's excellent. It's good. It's good. That's the way more Americans should be statistically literate. There'd be a lot less crap going on.
They should just be literate.
Well, literate period. But statistically literate in general, numerically literate. There's too much of a push for calc. You do not have a push for this kind of stuff. Okay, back to this.
Okay, yeah.
Woo! I'm here now. I'm here. Okay, so let's build this. You can't see this on the, we're going to build the distribution for the defect rates of the parts. So, we're in dist fill. Yeah, absolutely, 0 to 10. And Tabitha, I forgot about your question. The question you and Athena have is still unanswered. Okay, right now it's done. It's filled L1, just like this, just like 0 to 10. We got the binomial probability in, and Athena's correct, 0.005. The reason I even got off on that tangent about the about the .005 was, I think on your project you had to do .005. I think that was a chance of Lyme disease or something.
No, it's .00207.
There it was, 0.207%.
There it is.
It is, but that's the point. If it's that rare, the test needs to be better.
So we were talking.
Yeah.
And
Oh, yeah.
do you have you run the numbers on the chance for you to actually get Lyme disease twice?
Believe it or not.
You
No.
have?
But check this out.
Figured you
I
had.
not to be a bad pun. This is the reason I got infected with statistics in the first place. When I was in undergrad, I had to run a Monte Carlo simulation on something. My prof walked in and asked, "Your final project is a Monte Carlo simulation." We're like, "On what?" He's like, "On something." Everybody freaks out. I'm like, "Duh, I got this." I got Bell's palsy due to Lyme disease. Everybody ever have Bell's palsy or heard of Bell's palsy before? Left side of your face or right side of your face paralyzed for a short period of time, right? If you ever see me laugh really hard, one eye doesn't quite shut as much as the other. It's kind of funny. It's kind of funny. So I always wanted to know, what's the chance of catching Bell's, because Bell's palsy is not necessarily a symptom of Lyme disease. It's a tangential outlier symptom. So my question, of course, is how likely is it that I get Bell's palsy as a symptom of my Lyme disease? So I had to run a Monte Carlo simulation. Everything you do Monte Carlo is directly tied back to this problem. It's what's the chance I'm in a place where there are deer ticks, which is where Lyme disease comes from.
Right.
What's the chance I get bitten by one whose first meal was an infected deer mouse? Because that's where Lyme disease comes from, an infected deer mouse, which is about that big. And deer ticks, as you saw, are ridiculously small. What's the chance it goes to phase 1 undetected? What's the chance it goes to phase 2 undetected? And then finally, what's the chance it bumps up to Bell's palsy after that? All these conditional probabilities. Now, some of those are very high. What's the chance I'm in a place that deer ticks frequent? I was working in the woods as a groundskeeper for years. So I'm in the woods all the time on the East Coast. It's called Lyme disease because it was first diagnosed in Lyme, Connecticut.
Yep.
So I'm on the East Coast. I'm in the place where they are all the time. Okay, so boom, right there. What's the chance that I get bitten by one whose first meal was a deer mouse? It's been estimated, I think, between 40 and 60%. So half of them are, half of them aren't. So what's the chance it goes to phase 1 undetected? Pretty high. Those things are so, I've never found, I've had Lyme disease 3 times. I've never found, it was 2 in there. I've had it a third time, I think, since then. Only because I'm apparently prone to it now. Anyway, the things are so small, I never found the ticks that were on me. The symptoms showed up much later. So phase 1, which is basically seeing the tick and identifying small symptoms like stiff neck and things like that, didn't even notice it. Phase 2 is the rings, when they start showing the rings of targets. The targets usually show up around the bite site.
But they don't show up on everyone.
And they also show up in random places. I had a huge ring on my back, and since I'm not like flexing in the mirror every day, I didn't notice it. There was one on my foot, didn't notice it. I went to the doctor because my face went paralyzed. I'm like, oh my freaking gun. I go to the doctor, pull your shirt off. They're like, well, turn around. I'm like, okay. They're like, oh wait a minute, stand in front of the mirror, turn around. So I turned around and they like look up and they hold the mirror up the back, huge red ring on my back, which I never saw. I mean, I was like 19, 20 years old, living by myself, working out in the woods. So, I mean, pretty good chance I missed that too. So you string all these probabilities together, it gets less and less likely that I catch it, and all of a sudden it ends up being like a 1 in 10,000 chance or something ludicrous like that. Now, I never did the chance of the sequential, but the thing is, it's higher than you think it is. And this is related, believe it or not, to Athena and Tabitha's question, believe it or not. It's higher than you think it is because I kept working in the woods every summer.
Right.
And the test for it is terrible, as you saw. And the vaccine didn't exist back then, if there even is one now. Please.
So my boyfriend and his dad just got back from bear hunting, like, I don't know, a week ago.
Uh-huh.
Down somewhere like South Oregon, Southern Oregon.
mhm.
And they met someone down there who was in a wheelchair, was paralyzed from Lyme disease.
Yes.
And then they
Yeah.
came back and his dad had one in his shoulder and started getting rings and they said,
Oh, God.
oh yeah, you have Lyme disease, but he hasn't had any symptoms at all.
Well, and that's the thing. It's such a
It's
weird
like,
disease.
oh.
It can cause severe joint pains.
Uh-huh.
I got a stiff neck from it, basically. That was my only symptom, and the rings, which I never saw.
Yeah.
It's crazy. You can die from it.
Yeah,
It's all over the map as far as symptoms go, from a little tiny thing that you never said. Crazy. Anyway, let's see how that ties in what you guys are talking about. So we're here, 0.005, boom. You now have the entire distribution in L1 and L2. Done. The question was, what is the chance you're going to shut the machine down, which is what is the chance you have 2 or more defects? Now, in order to answer that, we have to go look at the numbers. Here we are. Now, right there in the top, what did I promise you, friends? What did I promise you, Jess? Go ahead.
Close to 100.
Yes! The highest probability should be, whoa, there's Mark. The highest probability should be 0 defects. Because you only have a 0.5% defect rate. That means 1 in 200. If you're only sampling 10, you shouldn't have any defects. And you can see right there, it happens about 95% of the time.
Yeah.
That's the most common. Go ahead, Eric.
You have 0.
Zero, 95% of the time. How about the chance of having 1? Roughly 5%, 4.7%. 2. Now here's where we're interested, right? Because if we get 2 or more defects, we're shutting the machine down. Well, according to those numbers up there, it looks like there's a roughly 99.9% chance that you're either going to have 0 or 1 defect, correct? There's a 99.9% chance, either no defects or 1 defect. Which means, what's the chance of having 2 or more? Everything else, right? 0.1%. So there should be a 0.1% chance of having 2 or more defects. Tabitha?
Is that because the sample size is so small?
Yes. If you sampled thousands, you'd expect more than 0 defects. But they also wouldn't shut it down for 2 or more in that case. They have to adjust it for the size of the sample.
Right. Okay.
So here's my question. That's the answer to the problem. The answer to the problem is the chance they're going to shut the machine down is 0.1%. Is that fair? Everybody see why it's 0.1%? That's the answer to the problem. Okay. Now, the answer to Tabitha's question was, wait a minute, why would they shut the machine down if they saw 2 or more defects?
Because it's so small of a chance there's probably something wrong with it.
Because it's exactly right, Cassie. According to this, you shouldn't see 2 or more defects. So if you are seeing 2 or more defects, this entire house of cards is built on that 0.5%. Chances are it's not 0.5%, it's higher than 0.5%, which means the machine is making too many defective parts. You see, what you just did was a proof by contradiction. If you see something you're not expecting, chances are what you were expecting is wrong. That's the basis of Math 244, believe it or not. That's inference. Yeah, so it was a great, I want to make sure I answered. It was a fantastic question. So yeah, that's why. And you'd have, like you said, you'd have to adjust it for a larger sample. But the same logic applies. You would expect this many on average, and if you've got more than that average, significantly more, you're popped out of standard deviations, shut the machine down, recalibrate it. Cool?
It's a really good machine.
It is? Yeah, 0.5%. Now, if they're making millions and millions of parts, I want to see it even lower than that. And this ties into something else statistically. Have you guys ever heard of 6 sigma? I don't know if you've ever heard of that. I'm not sure if it's more of an East Coast thing. 3 sigmas, 3 standard deviations. What percent of data do you trap in there? 99.7%, almost 100, 99.7%. And for years, 3 sigma was used as industry standard. If you're within 3 sigma, you're gold. You're getting parts so tolerances.
Oh.
So a bolt, for example, it's a 1/2 inch bolt. So 1/2 inch is the average, plus or minus 0.01 inches. So if you go out 0.03 inches up or down, you're still within the tolerances of that bolt. Everything is, and that works great for manufacturing. When computer technology came in and we started making microprocessors and things like that, 3 sigma wasn't good enough. You had to guarantee 6 sigma, which is even 99.9999996%. Because when you're making millions and millions and millions of parts, 99.7 isn't good enough anymore. Because 99.7% means out of every 1,000, you're missing 3. 997 are within, but 3 are without, right? So every million, you're missing a chunk of thousands of parts, and that was unacceptable. So they had to bump the control down, or bump the control out, to make sure that fewer were getting out of those control ranges. So it all comes down to tolerance. It all comes down to tolerance, and that's what you're referring to right there. Tolerance, not in like a, I can tolerate Sean's jokes for 10 weeks kind of way, but tolerance in a measurement kind of way. You're almost done, by the way. It's close. Last class. You're doing very well. Sorry. At least you take me in 244, it's the same jokes. I recycle them. Apologies.
What's Donna like?
Crap. What's that? She's confident. Unlike me. She doesn't come to class drunk like I do. She's actually a great compliment to it. It's actually great because she's. I love it. Because it's great because she's a trained statistician, so she comes at it from a much more traditional way, which is an awesome compliment to kind of like the more use it in the world kind of way I do. It's a really nice A and B kind of contrast. So she's doing it. You guys take it over the summer. She's doing the summer class.
I tried to take her.
Mm-hmm.
It didn't work out.
That's cool. It depends on personalities. I mean, it totally does. I mean, it's one of those things. So
She's a nice lady, though.
oh, for sure. And she's an awesome statistician. And I'm not. I'm a math guy converted over to statistics. And that's why I come at it kind of this way, is because I'm like, okay, I get what the formula says. I also get that you guys have had 12 plus years of formulas in your math classes, and you might not want to have a few more shoved down your throat. Let's play with it this way instead and get some interpretations. So, you want to take 5? Yes? Take 5, yes? Just more problems when we get back?
Get that blink look.
Get that glazed look. One more.